Before we get into any of our complex measurements, the first thing we're going to do is use our IO lab to determine the current that we are running through our wire. So you should already have your power supply set up. The first thing you're going to do is you're going to take black lead, you're going to put it into one of your grounds and connect that to the negative bar. And then you're going to take the red wire and you're going to connect it to analog 7 and the resistor that's on the negative side of your circuit. These two leads take voltage across one of your resistors. I'm doing it across this one right here. So now we're going to click on analog 7 so that we open up that. As you see, our vertical axis here is measured in voltage. Now it's time for us to close off our circuit. The first thing I'm doing, I'm going to take one of the ends. I'm going to stick that into the hole adjacent to the other resistor. Now once I connect this other one, then our circuit's going to be complete. Let's do that and then we'll take our data. Now let's hit record. I can immediately hit stop because all I need is a little bit of data. It should be a constant current, nothing's changing. I'm going to disconnect it so I don't wear down the batteries. You can even disconnect the IO lab because it doesn't need to be connected anymore. Take those leads out. Take your mouse and highlight a certain amount here, and it's going to tell you what the voltage was. We see that it was an average of 0.766 volts, and that was measured across a half ohm resistor. So using Ohm's law, we should be able to calculate the current supplied to our system. Alright students, now we're going to begin to take our actual measurements of the magnetic field using our IO lab. The first thing you're going to do is you're going to put your IO lab on the piece of paper. You're going to try to align the shorter edge of the IO lab so that it's parallel to that line and that the longer edge is perpendicular to that line that you drew. Now you're going to roll it back so that the back end of your IO lab is at the back end of the paper. Now you're almost ready to take measurements. So the 2 meters we're going to use are the magnetometer, as well as our wheel. At this point, you should make sure that your wire is connected to the power supply and everything is running correctly. Hit record. Move the cart nice and slowly and make sure you're rolling it so that the motion is rolling is perpendicular to the line that you draw, which is also perpendicular to the wire. Okay, 2 times should be enough. You could do it 3. Now we have our data. We're going to go to parametric. And the first graph we're going to look at is going to be by as a function of the wheel distance. So click this and change this from norm. And then we're going to select our data. And we have this unipolar graph of our data. What we're going to look for is our peak. We're going to confirm this peak using our formula for the magnetic field from a current carrying wire, and you're going to use 1 centimeter as your distance, or 0.01 meter. And we're also going to note the wheel position at which we meet our peak. You can use our highlighting tool, and the top seems to be about 27.494 microteslas, and the distance on the y-axis seems to be about 0.0933 meters. Now let's change our y-axis so that it is BZ instead of BY. So we're comparing that position where we found the peak in our BY versus wheel position. That should be the point of inflection of this bipolar graph for the BZ versus wheel position. And if we look at around 0.93, that seems to be about the inflection point. As we rolled our IO lab device over the wire, we see that the magnetic field is decreasing until we get to the wire, and then it flips, and now it's positive, and it starts decreasing as you go away from it. So that tells us which direction the magnetic field is on either side of the wire. So you should use this graph to figure out which way your current is flowing, or at least to verify the direction of your current.
Alright, now that we've finished the data collection, now we're going to test the shape of the magnetic field. So what we're going to do is we're unselect wheel, And right now on our graph, we have magnetometer versus magnetometer. We're again in parametric mode, and we're going to highlight the data that we have, and we're going to change our axes. What we want is we want to graph BY on the X and BZ on the Y. So one should take note of the shape that is on the screen. Please note on this graph the delta Y and the delta X, just like we did in the previous plot, as this will help you choose the best representation of your data based on the functions of R, of how the magnetic field falls off.